Hello everyone, my name is Yiqiao Xin. Just a bit of introduction before we do the demo. I'm a member of the CRSU based at University of Glasgow in Scotland, and I work on the MetaInsight development with Alex. Besides, I'm a health economist and work on trial and model-based economic valuations in health technology assessment. So in the next 25 minutes, I will demonstrate how to use the MetaInsight app. First of all, to access the app, you could go to the CRSU website by searching Google CRSU apps, then click the first link here, which brings us to the CRSU apps website. There are 3 apps on this web page. So in addition to the MetaInsight app at the top, as Alex mentioned, there are also MetaDTA, which is for conducting meta-analysis of diagnostic test accuracy studies, and the DTA Primer, which is an interactive tool designed to teach the basics of diagnostic test accuracy evaluations. If you're interested in meta-analysis of diagnostic test accuracy studies, please feel free to play around after this webinar. Now let's go back to the top and now click the link for MetaInsight. So this brings us to the home page of the app. We embedded in Google Analytics to get an idea of the app usage geographically. The app does not require you to sign up or input any personal information, so it will not record any personal identifiable information. And now I click I consent. So here we have the home page of the MetaInsight for continuous outcome version 1.1. So this is the basic version of the app, which contains the frequentist NMA. For each version, there is one for continuous outcome and one for binary outcome. So if you click the binary app link, then you can go to the binary app. Above that is the link to the version 2 app, which includes the Bayesian functions. You can also see the user guide download button here, where you can download and learn to use the app. So in this demonstration, we'll use the latest app, which contains the Bayesian analysis. So we click the link to access the app. So to avoid any memory loading issues of apps, because people may want to try themselves during this webinar, I will demonstrate using the same app, but just load it from my RStudio. So here we go. So it should be stable for this demonstration. So here is the home page of the MetaInsight version 2. On the right, it displays the new features since last update. You can click the link here to view a full update history of the app. Okay, so now we go back to the home page. Underneath the picture, you could find the author and contact information, the R packages that are used for developing this app, and declarations. So now let's click the next tab, Load Data. There are 2 steps for the data uploading process. Step 1 is to upload your formatted data file. One key thing is that the data file needs to be saved in the comma delimited CSV format. In your formatted dataset, the treatments are coded with numbers, so step 2 is to upload the treatment labels or names for each number coded in the dataset. Correctly formatting the data is very, very important to the app. If you're R user, you may know that R is extremely picky and any tiny error can make a difference. So on the main panel, we provided very detailed instructions on how to format your data. 2 formats are allowed in the app: the long format, where each row contains 1 treatment arm, and wide format, where each row contains all the treatment arms from 1 study. The app provided example datasets for users to download, which will be useful when formatting your own data. So once your data are uploaded, click the View Data page here. You will see your data displayed. The app is preloaded with dataset and treatment labels for the demonstration purpose, so we don't need to upload dataset for this demo. The preloaded dataset is from a network meta-analysis of interventions for obesity, and the outcome is BMI change. There are 24 studies comparing 6 treatments for losing weight. Okay, now we click the Data Analysis tab. On the main panel, there are 3 tab groups. Data Summary, which provides a forest plot of individual study result and network plot. And then Frequentist Network Meta-Analysis, which provides results from Frequentist NMA, and Bayesian Network Meta-Analysis, which provides results from Bayesian NMA. On the sidebar, there are radio buttons for users to specify their outcomes, model, and there's a list of studies for users to exclude in the sensitivity analysis. So now let's look at the functions one by one. And so firstly, on the data summary study results page. So this visualizes the individual study results in the forest plot. This plot does not contain the pooled results, so you can see there's no pooled diamond there, but there are 2 key information from this plot. The first one is that it tells you how much evidence there is for each comparison. For some comparison, there are many head-to-head trials, whereas for others, there are not many direct evidence available. And the second piece of information is that we can see the results from each individual study for each comparison. So in this example, you can see that when comparing, for example, sibutramine versus placebo, almost all studies have shown a statistically significant effect. So this plot can give us a general impression of the raw data, and we can use it to roughly predict what the pooled results would be like. So now let's click the next tab, network plot. The number on the line indicates the number of studies that provide direct evidence for that comparison. One very useful feature of the app is that it makes conducting sensitivity analysis of removing studies very handy. The results are displayed side by side. So sensitivity analysis and the primary analysis. So when you exclude some studies here on the sidebar, you will immediately see the impact on the network. Underneath the plot is the plot information, which tells us for this current network plot, there are 24 studies mixed comparing 6 treatments, forming 35 pairwise comparisons, and there is 1 connected network. So the distance matrix gives you the information to what degree the indirectness would be between each of the 2 interventions. So after observing the raw data and how network is connected, now let's click the Frequentist Network meta-analysis. So the analysis will automatically start running and show the results once you click each tab names. There are 3 sub-tabs: forest plot, comparison of treatment pairs, and inconsistency. So the first one, forest plot. It shows the pooled results of each treatment versus the reference treatment. On the left is the results for all studies, and on the right is the results with studies excluded. The default model is the random effect model. As you can see here, the selection is random effect. But if you want to conduct fixed effect model, you can click here, and then it will conduct fixed effect model. So random effect model assumes that the true effect is on the distribution. So it allows variability on the true effect, whereas fixed effect model assumes the true effect is 1 single treatment effect. So you can see that now with the fixed effect model, it tells you that the between study standard deviation set at 0. The Frequentist app allows the outcome to be either mean difference or standardized mean difference. So if the outcome in your data is standardized mean difference, then you can select there, and you will see the results in standardized mean difference. So now let's select back. The next result from the frequentist analysis is a comparison of all treatment pairs. This table provides two key information. Firstly, it shows the treatment ranking in the leading diagonal. Treatments are ranked from the most effective at the top left corner, in this case the Raymond, to the least effective at the bottom right corner, in this case placebo. So now, what is important for this ranking to be sensible is the ranking radio button here. In this example, the outcome measure is BMI change, so negative values would be desirable, and the more negative, the better. So for this radio button, we select small outcome values. So in this case, it means the more negative values, they're desirable. If you select the wrong one, undesirable, then you can see that the ranking is completely the opposite. So it is important to make sure the button is selected correctly before interpreting your ranking. So besides ranking, the second information on this table is the estimates on the upper triangle and the lower triangle. Above the leading diagonal is the direct estimate from the pairwise meta-analysis, and below the leading diagonal is the network estimate from the network meta-analysis. You can see there are some blacks here in the upper triangle there, which means there's no direct evidence available for that comparison. So looking across the leading diagonal, you can directly compare the direct estimate and the network estimate, as well as their confidence intervals, which provides you some idea in terms of inconsistency. But if you want to diagnose the inconsistency by applying some formal statistical tests, we can click the Inconsistency tab, which will show us the inconsistency test result, and it allows us to make some judgment about inconsistency. So it provides us the results for each comparison, including number of studies that provide direct evidence, pooled estimate from NMA, direct evidence, indirect evidence, and the absolute difference between the direct estimate and indirect estimate, and the 95% confidence interval for the difference, and the p-value. So generally speaking, from the frequentist point of view, when the p-value is smaller than 0.05, then we would say there is no strong evidence of inconsistency. So all the above are results presented from the frequentist network meta-analysis. Now we move on to the Bayesian network meta-analysis. All the tabs there shows all the functions that the Bayesian analysis is able to provide. I'll briefly talk about them one by one. Because the Bayesian analysis relies on simulations, which takes much longer time and memory to run, we added the running buttons here. So every time we change the radio button selections on the sidebar, no matter which tab you are at, you will need to come back to the forest plot tab and click this button to rerun the analysis. So this is different from the frequentist analysis, where, for example, if you select a few studies to exclude, the app will immediately start running after each additional study is selected. But here in the Bayesian analysis, you will need to click the button to tell the app that now the selection for the exclusion has finished and the analysis could start running. So now let's click the button, the run analysis. You could see there's a status bar here showing the progress of analysis. So now we have the results here from the Bayesian network meta-analysis. And underneath the forest plot are the model fit parameters. The Bayesian pages have the same layout as the frequentist pages, where the results from all studies are displayed side by side with the studies from sensitivity analysis. So next, we click the 3B comparison of all treatment pairs tab. You can see that a table is displayed. This table shows the estimate from network meta-analysis only, which is different from the frequency analysis, which also shows the pairwise estimate and the ranking. And this table doesn't show the ranking. The ranking is displayed in the next ranking table tab. So here we see a ranking table on the left and a median rank chart on the right. The ranking table shows the probability for each treatment to be ranked as the most effective treatment, rank 1, then the second most effective treatment, rank 2, and to the least effective treatment. In this case, there are 6 treatments in total, so rank 6. On the right is the median rank table, rank chart, which shows the median rank for each treatment option calculated based on the table. So the next is the node split model. So it runs the node split model to check the inconsistency between direct evidence and indirect evidence. This is a separate model from the NMA consistency model, so there is no result displayed for now, and you will need to click the button here to run the analysis. So same as the main analysis, you can see there is a status bar here showing the model is running. It takes much longer time to run as it fits a model for each pair of treatments that exists both direct and indirect evidence. So let's see, I can see from the background that it's running. Here we go. The results are displayed in a very similar structure, as you can see, as the frequentist analysis. Okay. The next is the Bayesian Results Details tab. This tab shows you the direct R output from running the analysis based on the GEMTC package. Below the output is the convergence assessment plot for the model. So this plot will be useful for deciding the number of iterations set for the burn-in period for the Bayesian analysis before we count the valid iterations for results. At the moment, the app runs 5,000 iterations for burn-in and 20,000 iterations for the results. But you don't need to worry about this now, as we hope in the future development we could add the options for users to be able to adjust these iterations based on this plot, and we'll put a description below it and add it to the user guide so that you can learn how to use this plot. Okay, the next tab is the deviance report. This tab provides 3 deviance checking plots and the deviance data output at the bottom. So the first plot can visualize the level of inconsistency. It displays the residual deviance from an inconsistent model against the residual deviance from the NMA consistency model. So the larger residual deviance means poorer fit. When the points are on the equality line, it means the inconsistency model cannot improve the model fit, so both the model have the same residual deviance. When the points are below the line, it means the MA model has a larger residual deviance compared to the inconsistency model, which means there may have some evidence of inconsistency. You can check out those descriptions underneath at your own time, and there are some further readings here if you're interested to study further. Then the plot below it and this leverage plot, those are simpler. They both show the magnitude of residual deviance from the NMA model. As I said, the larger residual deviance means poorer fit. So these 2 plots could help us determine which data point has poorer fit. so which means have larger residual deviance. So those are those ones. The data for these two plots are displayed in the data output below. So in the next update of the app, we hope to add the cursor hover over function, so that when you have your mouse over the point, you can immediately see which study these points come from, which should be quite handy for you to locate these outliers. Okay, so now the last tab, the model details. So these are just for those who are technical expert in NMA and want to know more about the model and values behind the results. Information on this tab is very technical, but you don't need it too much, so don't worry about it. Okay, so here are all the functions for the Bayesian analysis. We are at the moment writing the user guide for the Bayesian functions and hopefully to release it soon. And in the user guide, you can find detailed explanations of each tab and the functions.